Okay, so in this, we're going to graph a reciprocal function and go over all the possible properties of it. So first, what we have is this, the function of x is equal to 1 over x squared minus 4. So what I notice is that this is just a polynomial. I want to find its roots. So x squared minus 4 equals 0, and that is when x equals plus and minus 2. So these are the roots, right? So if that's when this equals 0, that means this is 1 divided by 0, which means I can't have that. So I say that my non-permissible values are when x equals plus minus 2. So I found the first part. Now, if I look at this, this also is the same as vertex form, right? So now I've found my vertex, which is 0, negative 4. So though these aren't the reciprocal function, they're actually kind of important because when we graph the reciprocal, we'll actually notice that it does have and is influenced by the parabola that is defined by this. So now I've got my non-permissible values, which my non-permissible values are my vertical asymptotes. So that is when x equals 2 and x equals negative 2. These are vertical asymptotes, lines that you cannot cross. The graph will never touch them. Now we also have something called our horizontal asymptote. And I'm just going to put the horizontal A. And this is when this graph, like a function of f, can never reach some value. And in this case, it's 0, because no matter what I do here, I can never get 0 out. It's 1 divided by a number, and that's always a number. So I have y can't equal 0. So now we have our non-permissible values, which is x cannot equal plus minus 2, which is our vertical asymptotes, and we've got our horizontal asymptote. Now, what we want to do is find the invariant points. So invariant points are when this and this are the same. So when the parabola and the reciprocal function are equal to each other. So what I would do is I just say, well, that's when x squared minus 4 equals 1 over x squared minus 4. So if I solve this, what I end up with is x squared minus 4 squared equals 1. And when I take the root, I have x squared minus 4 equals plus minus 1. So then we get two possible solutions. So I get x squared plus or minus 4 equals 1, and that is when x is equal to the plus minus root of 5. And the other option is when or x squared minus 4 is equal to negative 1. And that shows me that x is also equal to plus minus the root of 3. Okay, so now we've got a whole bunch of important points and values. So what I'm going to do is do this big graph. This is x and y. So now if we go here, this is at negative 2. We go here, this is 2. These are non-permissible values. And these are our vertical asymptotes. Nothing can cross these lines. We also have a horizontal asymptote right on this, right when y equals 0. This is x equals 2, and this is x equals minus 2. Now, I want to find the vertex of this parabola. So that's going to be at minus 4. And this is the root of the parabola, right? These are my roots of the parabola. And now I have the invariant points, which is 1 above and 1 below. So my invariant points happen when this is minus root 5, and this will be minus root 3, and this will be root 3, and this will be root 5. And the way that I knew this orientation of this, my all possible roots are plus minus root 5, so that if I just order them, that's minus root 5 is the smallest, then minus root 3 is the next smallest, then it's root 3, and then root 5 is the biggest. So when I have my invariant points, I just went through. So I know that 1 and up here and up here, these are the points on my graph. Now I have the vertex. If I had the vertex of this, the reciprocal of it would be a point right up here, which is then, I'll draw this graph in, but it's going to be like this. Now this tends to 0, and this tends this way. And the pattern of these graphs become more and more obvious. But the reason I wanted that vertex is because right here is the point 0, comma, negative 1 over 4. That might be a little hard to see. So that is essentially the highest y will go on this one section. If I try and rewrite that number, well, I could just call it point. Oh, I've run out of room in there. It's so tight with this Sharpie. But this is essentially the maximum height that it can go. So if we did the domain, that's the set of x such that x is an element of a real number and x cannot equal 2 or negative 2. Now if I did the range, that's y such that y is an element of a real number and it has to be bigger than 0, greater, not equal than, greater than 0, or y is less than or equal to negative 1 over 4. And we get this negative 1 over 4 from the vertex of this. This is the reciprocal, so 1 over that number. And that's how you graph a quadratic, the reciprocal of a parabola. And this is the parabola. Now if I try to get it in here. So that's the shape of the parabola. So the parabola hits this point, it hits this point, it hits this point, here, 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 here. So this is how we learn how to graph the reciprocal. The minimum here is the maximum here. This point is an invariant point. They both have this same point on their graphs. Same here, and here, and here. And this is their root. And that's how you graph the reciprocal of a quadratic.